day, sir. My name is Oyando live and R from Group 4. In this video, we are going to explain about the prototype we made. The basic components are the piezo, the breadboard, resistors, of course wires, the push buttons, and the Arduino. My groupmates will be explaining each and every component and explain their uses and functions. Here is Mr. Gallora to demonstrate the overall output of the system.
Good day, Engineer Nohai. I am going to explain and demonstrate the prototype made by Group 4 using TinkerCAD. The components used in this prototype are the Arduino Uno, the breadboard, the piezo, the push buttons, and the resistors. If the codes are correct, each button makes the piezo produce a different sound than the other buttons. There are 11 push buttons which create a unique sound. This is the demonstration.
Good day, Engineer Nagar. My name is Ira Nagar, and I will be discussing one of the components that we use. It is the push button. The function of push button is that when it is pushed, each push button will play different tone or pitch. These are the push buttons. Example here, this push button will sound different from this push button. This is
Good day, Engineer Noai. Good day to the viewers. I am Lauren Del Mundo, and I am here to discuss about the use of resistors in the Arduino circuit. So when building your Arduino projects, you use your resistors to limit the amount of current going to certain components in the circuit, such as LEDs and integrated circuits. So here in our prototype, as you can see, so we used of the following components: the push button and the piezo. So with the 11 push buttons located here, each are supplemented with their corresponding resistors. So each are further connected to the piezo to produce a sound. So as demonstrated by Mr. Gallora, so at every push button, as you press it, there is a corresponding sound that is produced. So in here, as you can see, in here, the first button, as it is pressed, it produces a sound. And the same goes to the other push buttons as you press it. And this is the purpose of the resistor.
Good day, Engineer Nohai. So my name is Joaqui Pagdonsolan, and today I am going to discuss about the uses and functions of piezo. So piezo, or a piezoelectric sensor, are versatile tools for the measurement of various processes. They are used for quality assurance, process control, and for research and development in many industries. So for a project, the piezo would produce different pitches due to different frequencies produced by the push buttons connected to the Arduino. So I am going to show you on how the piezo works on our project. So that's all. Thank you, sir.
Good day, Mr. Nohai. As explained earlier, in our prototype, we are going to use
a piezo as an amplifier that is connected to push buttons with different frequencies that creates different kinds of pitch. With this, we learned that entering different frequencies produces different kinds of sounds. This prototype can be a reference in making different kinds of instrument that is an electric one.
Good afternoon, everyone. I am Miguel Brena, and I will be explaining our codes for our prototype, which is the piano tiles. First of all, we will be inputting 11 buttons in our program, which is button 1, button 2, button 3, button 4, up to button 11. We will also input a buzzer, which is button 13, or we can rename it to buzzer, which is the last button. Anyways, we will be typing the pin mode for each button, so that if we will input a value for the button, it will be recognized. After that, we will be looping it so that when we press the buttons, it will generate a sound to the speaker. So we will use if statement for the first button, which is B1. We will use 1 and the tone of the buzzer, which has a frequency of 300 to 100. I mean 300 and 100. So next is button 2, which will increase the frequency to 400 and 100. Then button 3, 500 to 100. To button 4, 600 to 100. Until button 10, which is 1200 and 100. And if we reach button 11, it will be the highest frequency in our piano tiles, which is 2500 to 100. This is necessary because if these values will be all equal, the tone, we will not achieve a different sound for each button. So it is very important that all of these buttons are all of the sounds frequency of these buttons should be different, maybe in ascending order or in descending order, so that we will have a very different sound per button.
And that sums up every component and every function that we have in the system and in the prototype. That is all, sir, and that's for our prototype. Good day again, and thank you.